Good morning, 你好. Welcome to Blockchain and Lindy Chen channel. My name is Lindy Chen. I'm very excited to be here and share my insight about blockchain with you. In the last video, I shared with you evaluate the potential application of a smart contract in a decentralized peer-to-peer network. In this video, I will share with you applying smart contracts to solve problems. Blockchain picks up where the internet left off in terms of the expectation of problems the internet could solve. The ability of blockchain networks to create trust where there was none has been the game changer in terms of problem solving. It is the use of smart contracts in activating business logic on the blockchain that creates endless opportunity to solve problems. Let's look at some examples of typical problems that smart contract can resolve. Common language. Agreement across jurisdiction can be problematic from language, social, and cultural perspective and interpretation. Consider that smart contracts are written in code. As such, the contract is understandable for everyone across the globe, irrespective of the jurisdiction it is related to. High transaction fee and cost. Smart contract can automate many processes, which in turn can reduce processing costs. For example, investment banking has a real-life problem of high fees for payment operations and intermediary for different types of loans and credit transactions. Retail banker and a mortgage lender can cut costs for processing banking operations and the automation of insurance, both of which will create savings for insurer and the customer alike. Managing risk. One of the main risks associated with online or digital transaction is fraudulent behavior. Smart contract utilizing consensus validation and multi-signature can mitigate this risk by validating digital identity and excluding malicious parties from transactions. Intermediary. The internet promised the ability to remove middlemen from transactions, but a trusted party was mostly still required. Each middleman was trusted to ensure that their function occurred and would address any issue specific to their function. Hence, they were regarded as trusted parties. Consider a typical supply chain where goods are manufactured, passed to a distributor, who distributes to wholesaler. Retailers purchase from the wholesaler and on-sell to the end-user customer. It is reasonable to assume that through a simple use interface, the end user could simply place an order on the manufacturers and remove the other intermediary such as the distributor, wholesaler, and maybe even the retailer. Classic disintermediation. In practice, however, manufacturers do what they do best. Manufacturer. Distributor do what they do best. Build distribution channels. Wholesaler do what they do best. Service the retailer. Manage trading terms and shippings. Within each of these functions in the supply chain, these intermediaries are trusted to do what they do best, and each addresses issues specific to their function when things go wrong. It is not a stretch to build a set of business rules around this respective function and automate them. Smart contracts can use if-then construct to replicate these real-world issues and automate many of the processes. Smart contracts do not remove these middleman roles, but rather provide a digital and strictly rule-following middleman. They contain the logic rules that encode trust rather than humans relying on the trust of their human middlemen and customers. Furthermore, smart contracts can create immutable records of transactions and have little regard for geographical or time zone restraints. Another example that illustrates a significant problem-solving ability of smart contract is with banking system. The Society for Worldwide Interbank Financial Telecommunication, SWIFT, is used by many financial institutions to keep track of financial transactions. SWIFT uses a middleman bank for the completion of transaction payments between two or more banks. However, if one middleman redirects money, the bank and the SWIFT system may not be able to determine who the culprit is. The advantage of completing transaction via smart contract is that they do not use middleman service. In the context of the intermediary, consider the problems associated with middlemen, such as delaying transaction, committing fraud within a transaction, censoring information, terminating a transaction. This can be eliminated when a smart contract executes the agreed rules and autonomously apply if-then logic to the transaction. Direct business relationships. Smart contracts allows parties to quickly verify agreements, which in turn allows and promotes the establishment of direct business relations. Ownership of personal data. Currently, our personal data exists on any number of centralized servers, such as banks, Facebook, Google, HR and recruitment organizations, government and regulatory body, etc. There would appear to be a gap between what these centralized databases promote as their privacy policy and what is actually done with our information. With a smart contract, access to our personal data and records can be managed within the rule set in the smart contract. We can determine who can or cannot use our information. Access to our personal information can be concealed behind our personal keys, where proof of existence of that information may be all that is required. Consider a healthcare use case. The individual has a private key and is responsible for storing his personal data. This could also be applied to our critical surgery, medicine, or medical supply records. Not only is our information accurate, but it is also immutable and can be accessed quickly in times when it is needed, but only with access via the private key. Accessing big data. Many problems can be solved in a timely manner where there is access to the right information at the right time, information that can be trusted. Let's take a moment to discuss big data. When the internet first started, it was just a community of computers that were connected to each other. That community generated data, albeit not a lot in those early stages. As the internet gathered momentum, users and applications, the amount of data increased exponentially. Individuals and organizations determined that if they are going to be able to use that data to learn from it, access it, read it, create more of it in a manner that would allow other people to find it, they would need some kind of enhanced search capability. A major reason why search engines and later social media platforms were created. Large amount of data and information is increasingly being processed and stored for analysis by companies. Businesses understand that they can derive crucial insights from this data. Such insights can drive down costs, streamline operation, and lead to more informed decisions. Typically, this data is stored on centralized server with access on a user-pay basis. The same can be said for the Internet of Things and the current blockchain, where large amounts of data and information are being captured and stored in blocks. Oracles are being created together, analyzed, and stored on-chain, or maybe simply by a gateway to off-chain database, thus providing access to big data for problem solving. The Internet of Things is a rich environment of ecosystem that can use multiple smart contracts to interact with oracles, to use big data analytics, to create complex structure that execute automatically once multiple preconditions are met. From myself, the team at China Direct Sourcing, the team at Friesen Technology, and the team at Blockchain Collective, thank you for watching this video series. If you like what you see and hear and want to know more about it, please subscribe our channel and contact us. Good luck with your blockchain learning journey. Enjoy the program.